All right, here we go. Okay, folks, so looking at this, let's start at number one, because this is our end of the year review. This is the review for the district test we're going to be taking. And for number one, this is why. There we go. All right, this is an inequality problem. And you know, this is kind of like the beginning of the year when we have a problem on our plate. We just take some bullet points and write down what we know. So I'm going to read this. Your phone plan is $20 a month. 20 per month. Now, if it's 20 a month, that's a flat fee because you have a flat fee and then you got some other things on top of it. Let's see, another bullet point. You have $2.50 per international call. This is a variable, right? Because it doesn't matter, or it depends on who you call, how long you talk, all that stuff. Now, our budget equals $30. $30. Okay. So we need to write an inequality for how many international calls you can make. Okay, so this is a problem where, remember over here, we're going to put our budget. And over here, we're going to put what we spend. Okay, because let me tell you a scenario. You go into Best Buy, you go to buy a TV. The TV costs $110. You have $100. Can you go to the front of the line and say, hey, I'm a cool person. Can you give me this for $100? Is that going to work? Is that going to work? Has that ever worked in the history of buying something at Best Buy? Mm-mm. Maybe you could do that like a swap meet or like at a, if you're overseas, haggling is more traditional. But if you go into a regular store, people are going to be like, nope, if you got $30, you have to spend $30 or less. Right? There's my key right there. Now, this is all still based on y equals mx plus b because we only have one variable. And that is how many calls, how much money per call. So this is our rate, and this is our constant. Now, looking at this, which one of these is going to be constant no matter what? No matter what. Yep. $20 per month. It's a flat fee. Thanks, Kevin. So I'm going to go ahead and put 20 right here. I'm only paying per month, so I'm not going to add a variable to that. Now, $2.50 per international call. That's the part that's the variable. That's the part that's the rate. Okay, so the variable, has a variable to it, and it has a rate for how much it costs per value, per minute, per hour, per call. Okay, so I'm going to go ahead and put that here. 2.5x. Okay, cost per call, number of calls, plus the flat fee is something with 30. It relates. Now, can I spend $31? Nope. Can I spend $30? Yes. Can I spend $29? Is there any rule that says I have to spend all $30? No. I could spend $29. Could I spend $28? Yeah. So as I go down, $27. Yep. You could spend less than $30, but you can't spend more than $30. Okay. So if I can spend exactly $30, remember we're creating an inequality. An inequality, remember these? Okay. If we're creating an inequality, can you spend $30? Yes. It could be equal to the amount you have. But then think about it this way. How much you spend versus your budget. Which one of these, let's see, how can I explain this? Can I spend more than $30? Can I spend less than $30? I could spend less than $30. That's what we were trying to assume here. So I'm going to put a less than. The amount that I spend has to be less than or equal to $30. So here's my inequality. That's it, right here. Okay. So the key with this is you put the budget over here on the left. Put the budget on the left. You put how much you're spending, and then you're relating them. You relate them together. Okay. Number 1 is in the books. All right. Number 2. How about number 2? All right. Number 2 involves, let's see, you go to Craigslist and you find somebody selling a bike, but you get there and the bike wheels look like this. And you're like, I don't care. I'm a good bike rider. I can handle this. I can buy this bike. So you buy the bike and you're happy with it until you hit a rock this big and then you go flying. Okay. Now look at these wheels. Look at these wheels. What's wrong with these wheels? There's so much wrong with these wheels. Because our question is, what can be said about all the radii in a circle? All the radii in a circle. Remember that a circle is defined by the radius. Yeah, Tal. These are unequal. Look at this spoke. That spoke's way shorter than this spoke. Good, Tal. This spoke right here, right? Yeah. Yeah. So look, if I'm going to make a circle, I'm going to make it around this point right here. I know that this is the radius, and I'm just going to create a circle around it. And I didn't make that center very good. Let's see if I can do it. Whoa, can't already. I'm having a bad compass day. Get it. Got it. And my compass pencil broke. Perfect timing. Done with it. So look, here is the center. What do we know about all of the radii? All of the radii, which is plural for radius, all of the radii are what? They are all equal distance from the outside circle. Yeah, I mean, this is the main part. All these radii are always going to be the same. So what do we know? This is our answer for number 2. This is just the story. But all radii are equal length in a circle. I'm trying to give you a tangible example. If you ride a bike with wheels that don't have the same radius, it's gonna hurt because you're eventually gonna fall off it. Don't do that, guys. All right, let's keep going. I feel like I'm doing a podcast. I wish you guys can throw likes and stuff. That'd be cool. That's okay. That's what I gotta do. All right, look, we have some dots and we have some layers. So I'm gonna start drawing these things. Okay, we got 3 dots, right? So when we have one level, we have 3 dots. Okay, and then make a slightly bigger triangle. And here, if I have 2 levels, I'm not gonna do the dots all the time, but that's 6 dots. And then if I have 3 levels, I'd make all these dots, all the vertices of my triangles. And what do we have there? That's going to be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 3 levels get you 10 dots. Well. And then this one's going to take a little bit of work. And we have 4 levels, so I'll split it. Don't do that. We got 3. Got that one. Oh man, this is not a very good looking triangle. But when we have 4 levels, we have 15 dots. Okay. Now the question is, what are we going to end up with if we have 5 levels? Oh man, well that's not even close. You know what? Did I draw this? I did. I'm just going to draw. I'm going to show you what I have here. So I'll show you the final drawing in a second. But let's go ahead and what's a strategy? Like, what could we do? What could we do? If we were in class, you would be forced to answer. I'll beg you now, please. What is one thing we could do? We could make it seem like the teacher isn't talking to themselves. We could give a strategy. A table, awesome. You could do a table. What else could you do? What's another strategy? Thanks, Nikolai. What's another strategy to figure out what the 5 levels is going to be? 1 level has 3 dots. 2 levels, 6 dots. 3 has 10. 4 has 15. So what can we do? Make an equation. That would be a tricky one with this one, but we could do that. I like that. These are good strategies. Okay. And I like that. You know what, Kevin? I'm going to say making an equation is kind of like noticing a pattern first. You'd have to notice a pattern first. So let's do that. Let's notice a pattern. How do you go from 3 to 6? You add 3. Yeah, you know, a graph could happen after the equation. But I think all those options everyone gave is going to be finding a pattern. So I'm going to start by finding a pattern. Thank you for all the input, though. Find the pattern. 3 to 6, you add 3. 6 to 10, what do you do? Good, Tao. It is a sequence. Good. This is related to sequences. That's all patterns are. Okay. So we added 3 to get to 6. We add 4 to get to 10. We add 5 to get to 15. So how many are we going to add to get to a 5 level? This was 4 levels. We need 5 levels. Yes, Tao and Charlie have it. Tao and Charlie have it. Very good. So if we add 3, then you add 4, then you add 5. Clearly the next one is to add 7. Wait, that's not right. You add 3, then you add 4, then you add 5. Obviously, then you add 24. Wait, that's not right. What are you going to add? 3, add 3, then add 4, then add 5, then add 72? No. 6. You add 6. And let's see if that works. I drew this last time. There's a lot of fun stuff on it, but we won't look at that. And here we have, let's see, 1, 2, 3, 4, 5 levels. That's what we're looking for. And how many dots do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. I hate when I kind of hiccup right when I say a word. So we have 21 dots. 15 plus 6 gives us 21. So, hey now. Hey now. We got it. Okay, so that's about sequences. The key for this, y'all, is finding the pattern. How does it grow? How does it grow between each of them? Nice. All right, let's see what we have next. That was number 3, huh? Oh, number 4. My favorite thing in the world. No, it's not. But it is up there with favorite things. Systems of equations. Here we go. What are you writing? You're drawing it? No, you could draw that on your own. You could draw that on your own. Plus 6, that's all you needed. No, I'm not gonna stop to let you draw that. You could finish that. What do you need to look at? Maybe I'll put this over here. Put this over here so you can see it. Right? Okay. You're not gonna be able to keep up with this because I need to go quick. Yeah, we only have 8 minutes. So yeah, you can take a picture after. That's a great suggestion. So others will probably need it too, so thanks for asking. So here, look, we're going to solve this with substitution. Okay. Now with substitution, the main thing to remember is that this y is equal to this y. This x to this x. It's a system. That's what the squiggly line means. The bracket means that it is a system. So we need to decide which one of these equations do we want to solve for so we can plug in to the other. So you can pick either variable, you can pick either equation, whichever you want to manipulate. Yeah, I like that. I like that too. This one's the easiest one to manipulate. And why is the easiest? Because look, it already has it set up where it's y is equal to, and it's even positive. So if I want to solve for y, how about we just subtract 2x? Y is equal to, you can't combine these guys. You can't combine 7 and negative 2x because they're different types of terms. So we have to just rewrite them separate. And now we have a new system. We're going to put the first equation, which we just converted into this, we're going to put it back. Okay. And then we're going to put that second equation in there. Nothing changed with the second equation. Notice that these second equations are the same. We just converted the top one and then put it back. Okay. So now the key for this is, look, this y right here, y is equal to negative 2x plus 7. Since we know that is what y equals, we can put that quantity in for y, substituting it. So I'm going to take my bottom equation. I'm going to plug in that value that is equivalent to y. And now, you see, all we've done is, look at this second equation. The only thing we've done is, instead of putting y in there, we put what y is actually equal to. Am I frozen for everybody? Okay. So let's go ahead and distribute and see what we can get. Plus 8x minus 28 is equal to negative 18. 10x. Whoops, 27. Minus 28 is equal to negative 18. All right, so we're going to add 28 to both sides. All right. 10x is equal to 10. Oh my God, what's happening? X is 1. Yes, I'm done. I can go home. I'm done. Yay. Wait a minute. Maybe I'm saying it like that because I'm not actually done. Let me think about this. Am I done? Am I done, guys? What you think? Remember, this is a system. System. With systems, the answer, right? The answer is an ordered pair. 1. Yeah, we got to find y. We got to find y. So we found x. Now what we're going to do is take that equation that's easy to deal with. Let's bring it down here. Y is equal to negative 2x plus 7. Y is equal to negative 2 times 1 plus 7. You see, we're just plugging in for x to find our y now. And we end up with negative 2 plus 7. We end up with 5. Now I'm done. Now I can throw my pen down. Pen drop. Got it. Okay. Okay. So that's number 4. I think we might have time to talk about number 5 and maybe do number 6. Let's see if I can go quick enough. And then I'll give you a chance to take a picture of this in a moment. Number 5. Okay, so we just solved this last equation. We solved this last equation. Okay. And, you know, you see here at this point, we had combined through substitution the two equations, and we ended up with 2x plus 8x, okay? Minus 28 is equal to negative 18. We worked that out. We found what x is. There's going to be scenarios, though, for number 5 where you end up with this situation. After you combine, you might end up with this. You're like, remember these? You're like, oh, man. Because what is going to happen here? What's going to happen? 2x minus 2x is 0. You end up with this. You're like, dang it. I can't find my x value. And it's true. You're not going to be able to find your x value. That's mostly true. But I want you to pretend and think about this and say, well, what happens? What happens if, you know, if x is equal to 1? Let's see what happens. 2 times 1 minus 2 times 1 plus 3 is equal to 3. Let's see what happens. 2 minus 2 plus 3 is equal to 3. That goes away again. 3 is equal to 3. Dang it. But what if you're like, well, I mean, I hear what you're saying, but what if, you know, x is equal to 10? It can't be the same. Let's see. 2 times 10 minus 2 times 10 plus 3 is equal to 3. 20 minus 20 plus 3 is equal to 3. What happens to 20 times 20 or minus 20? Goes away. 3 equals 3. Dang it. They're always equaling 3 is equal to 3. The reason being is when you have your variables disappear on you, then any value you plug in for x will make this scenario true. So when you have your variables disappear and you end up with the same values, a true statement here, then it's infinite, right? Infinite number of solutions. Any value for x will work. Any value for x will work. Okay. That's counter to what if we had this situation? So what if we had 2x minus 2x plus 5 is equal to 11? Like, well, I can plug in any value. You know, I could plug in 1, get 20, or 2 minus 2, 10. You can get 20 minus 20. But it doesn't matter. These are going to go away. And then you end up with this. Oops. Is this true? Does 5 equal 11? I wish this was true. So you can go into a bank. You're like, here's $5. Give me 11 bucks. You'd be rich. You wouldn't have to work ever. This isn't true. So when you lose your variables and you end up with the same value, infinite number solutions, because you could put any value in for x, like we did here. We put in 1. Here we put in 10, right? But if you end up with two numbers that do not equal each other, then there's no solutions. Okay? That's the difference. I hope that makes sense. Because look, there's no solution. There's no value for x you can put in here that will make 5 equal to 11. You see what I mean there? Because the variables are going away. So really, really straightforward for number 5. If the variables are canceled and negate out so there's no variables left and the numbers equal each other, then any number will work as a solution. Infinite number of solutions. You can put in 1, you can put in 2, 3, 4, 5, 6, 7, 8. Still is going to be 3 equals 3. If your variables negate and you end up with two different values, then there's no number. There's no number for x you can put in here that will make that happen. So there's no solutions. Those are our two options. And I think I'm going to have to stop the video now because it's time to go. And I don't want to leave.